Hello everybody. In this presentation I will shortly speak about how we can revolutionize food allergen detection. So at the moment food allergens are mainly detected using immunoassays such as ELISA in the lab. And the problem with these assays is that they are quite slow and low throughput. Also they suffer from positive and negative bias that can be caused by immunorecognition variability, as well as protein degradation and protein modification that can basically hide or change the epitope that is being recognized by the antibodies used in an ELISA system. So this is a suboptimal system, and I think that it can be tackled by using a two-sided approach, with on the one hand using a lab-based LCMS quantification method that does not have these type of cross-reactivity issues or problems with protein modifications that will make it impossible to see the epitopes, because instead we are just looking at a linear peptide sequence when we are doing mass spectrometry. So that would be on the first side, and then on the other side we could try to use on-site smartphone hyphenated detection. So here the idea is to use paper-based or liquid lab-on-a-chip devices that can be photographed with a smartphone, and then quantify the color intensity in those assays, and immediately register that in the cloud and use that as a first screening test. So by combining these two methods, on the one hand have this type of really accurate confirmatory high throughput analysis in the lab with LCMS, and on the other hand have a very rapid and easy to use smartphone based biosensor for the detection on site. Combining these two methods creates a multiple layer security system in which you can first of all test a lot more samples, because you're using a smartphone for the testing, for the first screening assays, so it's very rapid. And on the other hand, be very sure that you don't have any false positives or false negatives coming in to make problems, because you have a confirmatory analysis behind it. So what I'm showing here in this poster is that I've basically developed both sides of the story. So on the one hand, I've worked on setting up a quantitative LCMS method for peanut allergen detection, which you see in figure 1, and then in figure 2 you see a smartphone based assay that I've developed that enables actually the quantification of colorimetric paper based as well as liquid assays. So just to speak a little bit about the performance of the first method, so the LCMS method, we've tested various buffers and we found that it's very important to pick the right buffer, because if you pick the wrong buffer you can get good results in one matrix but totally different results in another. And also what you can see is that the variation that you get between different variants of varieties of peanuts can be huge if you don't pick the right buffer. So that's really critical. And then a second thing is to use matrix matched calibration curves once you go to quantification. So here you can see the red line, it's a matrix matched calibration curve. It's quite different from the buffered one. Both of them have good R-square values, but if you would interpolate on the buffer curve, you would definitely get more errors in your recovery. So this system has been set up. It has been optimized for rapid analysis, because of course we want to do this high throughput. So through omitting a few complicating steps by doing the right peptide selection, we managed to get to a system that takes about 2.5 hours to analyze the peptides, including 1.5 hours of labor, with a limit of quantification at 0.5 ppm and a recovery rate between 73 and 106%. This was for peanuts, peanut muffin and peanut ice cream. And if you compare that with the literature, you can see that it's really a step forward, because there you have about 2.5 to 5 hours of labor and a total analysis time varying between 6 and 20 hours, with a much higher LOQ and worse recovery rates. So this method is definitely an improvement to that. And then on the right side, so figure 2, I just show a smartphone based system that we've previously published. So here what we did is take images with a smartphone from different paper based and liquid assays, including a plasmonic ELISA, pH strips, and different lateral flow assays for food allergens. and then extracted the RGB values from the pictures, did some background light corrections on them, and used them to predict errors, which is the last error bar picture that you see in that image. And as you can see, if you compare it with a spectrometer, you actually see that some of the optimized channel values have very similar error rates as a benchtop spectrometer, showing really the power and the potential of using a smartphone camera for this type of analysis. So as a conclusion, I think that combining LCMS and smartphone-based on-site analysis is a great tool for improving food safety testing for allergens. However, I do think that to avoid false positives, it's really critical that the smartphone technology should not be implemented as a standalone technique, but rather be introduced in concert with a confirmatory method to ensure that we have this unambiguous confirmation of each generated positive with a smartphone, to avoid issues with massive amounts of testing with such a rapid technique and then potential high amounts of false positives. So that's it. Thank you very much for listening to this presentation. And if you're interested, please contact me by email.